Hello and welcome to part 3 of this video where we're looking at a GCSE exam paper from Pearson Edexcel. This is the November 28 series and it's paper 1 non-calculator. We're up to question number 19. Let's begin. 19. Rotate shape A 180 degrees about 1, 0. Now in a real exam this is a question where you would often use tracing paper in order to do this. So using tracing paper on this sort of question means you have to do two things. One is you need to identify the centre of rotation. That's the coordinate that's given in the question. So our centre of rotation is 1, 0, which is there. Now what you would then do is place tracing paper over this question so that it covers both the shape and the centre of rotation. Once you've done that, you would draw, as I have done in blue here, around this shape, and then you would also mark where the centre of rotation is. You would then use something sharp, so either a pen, pencil or compass point, to dig into that point so that you can rotate the tracing paper freely. Now a rotation of 90 degrees would be a quarter turn. A rotation of 180 degrees is a half turn. So if I take this shape and rotate it, this is almost like the tracing paper moving. So 90 degrees would turn that shape there, but we want to go the full 180 degrees, which takes the shape down there. So there is our answer. We have rotated the shape 180 degrees about 0.10. Question 20. Work out the value of 3 to the power of 7 multiplied by 3 to the power of minus 2 divided by 3 to the power of 3. Now this is a non-calculator paper, so you will not be working these numbers out. They are going to be very big and very small in the same question. So instead, this is a laws of indices question. There are rules to how we simplify index numbers when we've got the same bases. So let's start with the top. You've got 3 to the power of 7 multiplied by 3 to the power of minus 2. One of the laws of indices tells us that when we are multiplying these things together, what we are actually doing is adding the powers. So what we're actually doing is 3 to the power of 7 plus minus 2. Now when we have this situation where we have two symbols next to each other and they are both different, so a plus and a minus, that means that overall that effect is a minus. So this is 3 to the power of 7 minus 2, which is 3 to the power of 5. So there's the first part of the question. The top of this simplifies to 3 to the power of 5. The next part is that we're going to be doing 3 to the power of 5 over 3 to the power of 3. Now when we have something that looks like a fraction, this line actually means divide. This is 3 to the power of 5 divided by 3 to the power of 3. One of the other laws of indices tells us that when we are dividing two numbers like this, we are subtracting the powers. So this is actually 3 to the power of 5 minus 3. And 5 minus 3 means that this whole answer becomes 3 to the power of 2, or 3 squared. Now the question wants us to work out the value. Now when it's saying the value, that means it wants the actual final answer, a single number, not an operation. So 3 to the power of 2, or 3 squared, means 3 times 3, which means our final answer is 9. Question 21. V squared equals u squared plus 2as. U equals 12, a equals minus 3, s equals 18. Work out the value of v. Now this is a real equation that works out differences between distance, speed, time, acceleration. V is basically what's an ending velocity, so how fast something is going after an application. U is an initial speed, so how fast something is going at the start. A is the acceleration, and s is something called displacement, which is basically the distance travelled. So all we're doing is using these numbers and putting them into this formula. So v squared is equal to u squared, so that's 12 squared, plus 2as means we're doing 2 times a, which is minus 3, times s, which is 18. And we're going to work that out separately. So first of all, 12 squared is 144. To that we're going to be adding 2 times minus 3 times 18. You can do this in any order. So for example, 18 times by minus 3 is minus 54, and 2 times minus 54 is minus 108. Once again, we have this situation where we've got a plus and a minus next to each other, so that's overall going to be 144 minus 108, and that gives us an answer of 36. Now that's not our final answer, that's the value of v squared. So if v squared is equal to 36, if we only want v, we need to do the opposite of squaring, which is a square root. And the square root of 36 for this question will be 6. Part B. Make s the subject of v squared equals u squared plus 2as. Now the subject of a formula is the letter that's on its own on one side of the equal sign. So we need to make s on its own. Now you can do that in a couple of ways. You can use the skills of balancing equations to remove the u squared and remove the 2a, or you can use a function machine, and that's what I'm going to use. So to use a function machine, we need to figure out what happened to s and in what order. So if we start at s, what's the first thing that happens to that s? It gets multiplied by this 2a. So the first thing that happens to the s is that it gets multiplied by 2a. In a function machine, that is written like that. Once that's been done, we are then having that added on to u squared. So we're going to be adding u squared onto that. And that gives us v squared. In order to make s the subject of this formula, all we're going to do is put v squared backwards through this machine. So v squared is going backwards, which means that we do the opposite of what's in the boxes above. So the opposite of plus u squared is minus u squared. So when that comes out of that box, we've done v squared and we've minused u squared. Then the opposite of times by 2a is divide by 2a. So when that comes out, we've taken the v squared minus u squared and we've divided it by 2a. These two things are now equal, and so s is equal to v squared minus u squared divided by 2a. Now be very careful about how you write this. When I've divided by 2a, I have purposely written it as a fraction, so that it's showing you you're dividing v squared and the minus u squared both by 2a. Just to show you a wrong answer, if you wrote that s is equal to v squared minus u squared divided by 2a, that would now be incorrect, because if you were calculating with numbers, you would be using BIDMAS, which means you'd only be dividing the u squared by 2a, and that would not be correct. We are dividing the answer to v squared minus u squared, all divided by 2a. So there's the correct answer. Question 22. A bonus of £2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers. The rest of the bonus is shared equally between 7 salesmen. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. Is the salesman correct? You must show how you get your answer. So we need to work out how much money the salesman will get using the original scheme and using his own scheme of dividing everything equally. So let's start with the company's version. So this bonus of £2,100 is being shared by 10 people, but 40% of it is going to the 3 managers. So we first of all need to work out 40% of £2,100. Well, 100% is the full 2,100. We can now work out 10% by dividing 2,100 by 10 to get £210. So 10% is 210, and so to work out 40%, we do 210 multiplied by 4, which is 840. Now that's going to the managers, which means that what's being given to the salespeople is what's left out of the original £2,100. So we're going to do 2,100 and subtract that 840 to find out that the salespeople will be sharing £1,260 between them. Now that's being shared between 7 salesmen. So we need to do 1,260 and divide that by 7 to work out how much each salesman will get. You can do that any way you wish. The answer to that is £180. So each salesman under the original scheme will get £180. If the bonus is shared equally between all 10 people, that would be 2,100 divided by 10, they would each get £210. Now he thinks, one of these salesmen thinks, that they will get 25% more money if they have £210 rather than £180, and we need to show whether that is true or false. So what we need to do is take the £180, work out 25% of it and add it on, and then compare the two answers. So you're working out 25% of £180. I'll leave you to choose whichever method you want for that. You could work out 10% and 5% and add bits together, or you could recognise that 25% is the same as a quarter. Either way you do that, that would be £45. So 25% more than 180 will be 180 plus that extra £45, which would be £225. Since that number there and that number there are different, the answer to this question is no. £210 is not more than 25% extra on top of £180. Question 23. It would take 120 minutes to fill a swimming pool using water from 5 taps. How many minutes will it take to fill the pool if only 3 of the taps are used? So we need to work out the relationship between the number of taps that are in operation and the time it will take to fill. So if we're using 5 taps, it uses 120 minutes. We now need to work out eventually how long it will take for 3 taps. But we can't do that in one step. We need a middle ground, and that's to work out how long it would take if we were only using 1 tap. Now if that one tap had to do all of the water that all 5 of these at the same time would do, it would take 5 times as long. So we're doing 120 times 5 to work out that it will take 600 minutes if only one tap was in use. It would take longer because there are less taps pushing water into the swimming pool. If we then have 3 taps, the work of that one tap can be split equally between these 3, which means that we can divide that 600 by 3 to work out that 3 taps will take 200 minutes. And that's our answer. Part B. State one assumption you made in working out your answer to Part A. Now this is always about what these taps are doing. These questions are very common with taps and also people doing a job, and the assumption is always that each of these taps are going to work at the same rate. So in this particular case it means that we are assuming that all 5 taps from this question are all flowing water at the exact same rate. So one's not going faster than the others and pushing more water out. We're assuming they're all the same. Question 24. A plane travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. So at the moment we're doing 213 miles in 1 hour. I'll call this time. I'll call it hours. Now when we're working out an estimate, we usually round one of the numbers. Most of the time we're rounding more than one number, and it's usually to one significant figure. Basically we don't want to be using a number of 213, that would be difficult to use, so we're going to round the 213 miles so that we're only using 200 miles in 1 hour. Now we need to convert the hours into seconds. So, a couple of facts that we need. 1 hour is the same as 60 minutes. So this 1 hour is the same as 60 minutes. And 1 minute is the same as 60 seconds. So if we've got 60 minutes, we've got 60 lots of 60 seconds. So that's 60 times 60 to get 3,600 seconds. And in all these cases, we'll be using 200 miles. We now need to work out the number of seconds it takes to travel 1 mile, so we need to turn the number of miles into 1. Depending on how confident you feel, you could do 3,600 divided by 200, or you can do this in 2 steps and simplify it further. So for example, if I halved 200 to get 100, I would halve the number of seconds, which would be 1,800. And then I can divide by 100, so 1 mile will take approximately 18 seconds. Part B. Is your answer to Part A an underestimate or an overestimate? Give a reason for your answer. Now usually you'll tend to find that if you are rounding a number down to a smaller value, you tend to get an underestimate. But that's not the case in this question, and let's have a look why. So the actual question was 213 miles in 1 hour. We now know that 1 hour is the same as 3,600 seconds. So if we were doing this for real, we would be doing 3,600 and we would divide that by 213. What we actually did was 3,600 divided by 200. And if you divide an amount by a smaller number, you get a bigger answer. So for example, 100 divided by 20 is 5, but if I divide it by a smaller number, so 100 divided by 10 is 10, you get a bigger answer. So 3,600 divided by 200 will be a bigger answer than 3,600 divided by 213. Therefore, our answer is an overestimate. And the reason for your answer would be that you are dividing by a smaller number, which will give a bigger answer. Question 25. Solve the simultaneous equations 5x plus y equals 21 and x minus 3y equals 9. When we're solving a simultaneous equation, we need to make the numbers either in front of the x's or in front of the y's the same. And it doesn't matter which one you do, it just changes which part of the question you work out first. Now, you tend to find it easier if there are different symbols, or a plus and a minus. It tends to be easier to find out what they would be if they cancelled. So I'm going to make the y's the same in this question. So we've got 3y in the bottom part, which means we need to have 3y in the top. So in order to turn that top equation so it's got 3y, I'm going to multiply every part of it by 3. So 5x times 3 is 15x, plus y times 3 is 3y, and 21 times 3 is 63. And then I'm going to rewrite the bottom equation underneath. So sometimes you'll have the situation where you are just changing one number in one equation. Sometimes you might have to change both equations if there's no easy way to turn one of the numbers either in front of the x's or the y's into the same thing. Now that these y's are the same, we're going to need to get rid of them. Now, I tend to use a system called DAS in this case. Now that stands for different, add, same, subtract. And that's basically saying that when we've got these symbols in the middle, if they are different, in which case these are, because we've got one plus and one minus, then we're going to add the two equations together. If they were the same, so they were both pluses, then we would subtract one equation from the other. So we are going to take these and we are going to completely add them together because these signs are different. So with the x's, 15x plus x is 16x. 3y plus minus 3y is 0. They cancel each other out. And that's what we want. We want one of the letters to cancel out, which then leaves us with 63 plus 9, which is 72. We can now work out the value of x by doing 72 and dividing it by 16. Now you can do that any way you wish. I'm going to count up in 16s. So 16, 32, 48, 64. So that's 4 whole amounts. So that is going to be 4. So 4 16s is 64, which leaves us out of 72 with 8 left over. So what we've basically done there is converted an improper fraction into a mixed number. 8 over 16 can be simplified to a half. So this will either be classed as 4.5 or 4.5. So x is equal to 4.5. Now that we know that, we can work out what y is. Now once again, you can do that however you want. I'm going to use the top equation. So we know that 5x plus y equals 21. We know that x is 4.5. So 5 times 4.5 plus y equals 21. 5 times 4.5 is 22.5, and once again you can do that however you wish. You could do 5 times 4 to give you 20, and 5 times a half is half of 5, which is 2.5, and add them together. So 22.5 plus y equals 21. Now, since 22.5 is already bigger than 21, that means that y is going to be a negative number. So what do we need to subtract from 22.5 to get down to 21? Y is going to be minus 1.5. You could also do 21 minus 22.5 to get that answer. And there's our solutions. X is equal to 4.5 and y is equal to minus 1.5. Question 26. The diagram shows a square ABCD with sides of length 20 centimeters. It also shows a semicircle and an arc of a circle. AB is the diameter of the semicircle. So this line here, AB, is the diameter of this semicircle, which means you can imagine there being a full circle with a diameter of 20 to give that semicircle. AC is an arc of a circle with centre B. Now, if B is the centre of this much larger circle, that means that that must be a quarter of a circle, because we would have a 90-degree angle here. We need to show that the area of the shaded region divided by the area of the square is equal to pi over 8. Pi divided by 8. Now, in order to do this, there's 3 things we need to work out, and that's the areas of the 3 shapes that we can see. We can see a semicircle, we can see a quarter circle, and we can see a square. We need to work those out separately. So for the semicircle, we know the diameter is 20 centimeters. But if we're working out area, the formula for the area of a circle is pi r squared, which is pi times the radius squared. So if the diameter of this semicircle is 20 centimeters, the radius, which is just half of it, will only be 10 centimeters. So the full circle, so imagine we don't have a semicircle, the full circle would be pi times r squared, which would be pi times 10 squared. 10 squared is 100, so that is 100 times pi, and that's written in terms of pi as 100 pi. But that's the full circle. We only want the semicircle, which means we need half of that, so we're doing 100 pi divided by 2, and 100 divided by 2 is 50. So the semicircle is 50 pi centimeters squared. Now for the quarter circle. Now once again, we're dealing with a full circle would have an area of pi r squared. Now the radius of the full circle, let me just draw this in so you can see it clearly. The radius of the full circle would be this distance here, which we already know from this question is the full 20 centimeters. So in this case, the full circle would be pi times 20 squared, and 20 squared, which is 20 times 20, is 400 pi. But we don't want the full circle, we want a quarter of it, which means this time we're going to do 400 pi divided by 4, which means the area is going to be 100 pi centimeters squared. And finally, the area of the square, well, the square has a side of 20 centimeters, and the formula for the area of a square or rectangle is going to be base times height. You can call it length times width. I tend to stick to base times height because it works for more shapes and makes people less confused when it comes to triangles. Base times height in this case is 20 times 20, because a square has equal sides, which means the area of the square is 400 centimetres squared. Right, now we've got all of our parts, we now need to put it together. The area of the shaded region. Now if you look at the shaded region, that's the full quarter circle with the semicircle cut out of it. So the full quarter circle was 100 pi, but we're cutting out, which means minusing the semicircle, which is 50 pi. And that's going to be divided by the area of the square, which is 400. Now when we simplify that, if we've got 100 pi and we subtract 50 pi, 100 minus 50 means that is going to be worth 50 pi. And that's going to be divided by 400. Now this is a fraction that we can simplify. We can count how many 50s go into 400, and we find out that's 8. So this will be worth 1 pi over 8. And that is what we wanted to show. So the area of the shaded region is pi over 8 centimetres squared. Question 27. Amina has 2 bags. In the first bag there are 3 red balls and 7 green balls. In the second bag there are 5 red balls and 4 green balls. Amina takes at random a ball from the first bag. She then takes at random a ball from the second bag. Complete the probability tree diagram. Right, if we know that 3 out of the 10 balls in the first bag are red, and we know that 7 therefore out of the 10 are green. From the second bag, 5 out of the 9 are red and 4 out of the 9 are green. That doesn't change for the bottom set. Still, in that second bag, 5 of the 9 are red and 4 of the 9 are green. So we've completed the probability tree diagram. Part B. Work out the probability that Amina takes 2 red balls. If we're doing 2 events and trying to work out a total probability, that means we need to take the 2 individual probabilities. So in this case, the probability of getting the first red ball is 3 over 10. And then we need to take the other probability of getting a red from the second bag, which is 5 over 9. And to combine them, you multiply the probabilities together. So 3 times 5 is 15. 10 times 9 is 90. You could simplify that if you wished, but the question did not tell you to, therefore I'm going to leave my answer as 15 over 90. And finally, question number 28. The size of each interior angle of a regular polygon is 11 times the size of each exterior angle. Work out how many sides the polygon has. Now before I move on to the actual question with one angle being 11 times the size of the other, let's have a look at the relationship between interior angles and exterior angles. So if I take a pentagon, the angles that are found inside the shape are the interior angles. So that there would be an interior angle. I'm going to label it with an I. Now people often mistakenly think that the exterior angle would be the angle on the outside to make it into a full circle, but that's not correct. An exterior angle is found when we extend the side onwards. The exterior angle is this angle here. Now we know that there is a fact that if we've got these angles on a straight line, these must add together to give 180. So the interior angle plus the exterior angle will total 180. And now to this question. The size of each interior angle of a regular polygon is 11 times the size of each exterior angle. Now you can do this using a bar model, or you can use algebra. I'm going to use algebra for this one just to show a variety of different question types. If you want to draw boxes like we did on the lemonade and orange juice question from earlier, you can do. You could draw 11 boxes for the interior angle and 1 box for the exterior angle. So 11 times more boxes. For this, I'm going to call this angle X. And we know that the interior angle is 11 times the size of the exterior angle. So if the exterior angle we call X, the interior angle will be 11 times that size. But we know that when we add the two together, it must total 180. So how many x's do we have in total? Well, 11x plus another x means we would have a total of 12 x's. If you're doing this in boxes, you'd have 11 boxes and 1 box. That gives you a total of 12 boxes. It's the same thing. So 12 x's is 180. And so we are going to be doing 180 divided by 12. So x is 180 divided by 12. So x is 15. Now that's only the first part of this question. We want to work out how many sides the polygon has. And that comes from another fact. Each of these exterior angles, and there will be several of them because they will continue around the shape, also have a second property. In that if you take all of the exterior angles, so all of these angles, and put them together, no matter what type of shape they come from, exterior angles will always add up to 360. So all the exterior angles adds to 360, and the number of exterior angles we have is the same as the number of sides the shape has. So we know that each exterior angle of this question is 15 degrees. So to work out the number of sides, we need to take the total degrees of the exterior angles, which is 360, and divide that by the size of each angle, and that will tell us how many angles there are. 360 divided by 15, however you wish to go about that, will give us an answer of 24, which means that this polygon has 24 sides. And that is the end of this exam paper.